Hello everyone, welcome to Math Smart Tips. In this lecture, we will discuss some important results and inequalities in probability. To read probability, these results and these inequalities are very important. So let's start the video, and before starting the video, I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. And in the previous video of probability theory, I already discussed the Bayes theorem and some other topics, so I will share the link in the description and also here in the I tab. Those who are not watching the videos, you can check the videos link of the videos and watch the videos for your help. So probability, the first result is probability of an impossible event is 0. That means P of phi is equal to 0. This is a very useful and easy result. Number 2 is probability of complementary event A complement of an event A is given by probability of A complement equal to 1 minus probability of A. We all know this result also, and it is the obvious result. The value of the probability lie between 0 and 1 of any event A. So the number 3 is for any two events A and B, probability of A complement intersection B, this is equal to probability of B minus probability of A intersection B. And similarly, the number 2 is probability of A intersection B complement. This is equal to probability of A minus probability of A intersection B complement. This one. And if we write the Venn diagram, then this is the event A, this is the event B, and S is the complete event space, and this portion is the A is complement intersection B portion, and this portion is the A intersection B complement portion, and this portion is A intersection B portion. We all know that, the Venn diagram. Now the next one is if B subset of A for any two event A and B, A intersection B complement, this is equal to PA, probability of A minus probability of B. So B subset of A means A, this is the event A, and inside A there is an event B, and this is the portion A intersection B complement. So we have probability of A intersection B complement, this is equal to probability of A minus probability of B. These results are very important to do the sums of problems of probability theory. So let's the next one is probability of B less equal to probability of A. If B subset of A, then probability of B less equal to probability of A. The number 5 is for any two events A and B, number 1 is probability of A, this is equal to probability of A intersection B plus probability of A intersection B complement. Probability of B equal to probability of A intersection B plus probability of A complement intersection B. Number 2 is probability of B given A, this is equal to probability of A intersection B by probability of A, and probability of A intersection B is equal to A given by this is the B, this is equal to probability of A intersection B given by probability of B. From this result, the multiplication theorem probability will come. We will discuss in the next. So number 3 is probability of A complement intersection B complement, this is equal to probability of A union B whole complement, this is equal to 1 minus probability of A union B. The next one is number 4, probability of A union B, this is equal to probability of A intersection B complement plus probability of B, and this is equal to, we can also write probability of A complement intersection B plus probability of A. The next one is probability of A complement given B, this is equal to probability of A complement intersection B by probability of B provided probability of B non-zero. This is, if we simplify this, then we can write from the above result probability of A complement intersection B, this is equal to probability of B minus probability of A intersection B by probability of B, and if we divide this, then we get 1 minus probability of this term means probability of A given B. So this, if we simplify this result, then we get this result, the last line. Also probability of B given A complement, this is equal to probability of B intersection A complement by probability of A complement. If we simplify this above, this one and this one, the numerator and the denominator, then we get probability of B minus probability of A. This is a standard result. This is equal to this probability of B minus probability of A intersection B by 1 minus probability of A, as we discussed above. The next one is probability of B complement given A complement. this is equal to probability of B complement intersection E complement given by probability of A complement, and we can write probability of B complement intersection E complement equal to probability of B union A whole complement. This is equal to 1 minus probability of B union A, and in the denominator we can write 1 minus probability of A, this result. Now we come to a most important result on probability, that is addition theorem. This is a very important theorem and very powerful theorem on probability. So if A and B are two events, we start this addition theorem by any two events, and then after that we extend this for n events. So if A and B are any two events with subset of sample space, that is the events A and B are subsets of the sample space S and are not disjoint, then we can write probability of A union B, this is equal to probability of A plus probability of B minus probability of A intersection B, and from this result we get an inequality. We can write probability of A union B. Now these two sides are equals, so this term, since we subtract probability of A intersection B, this is a positive quantity, since probability is a positive quantity, non-negative quantity. So if we subtract a non-negative quantity from this, from a quantity to get another quantity, then this quantity must be greater than this quantity. That means we can write here an inequality, probability of A union B is less equal to probability of A plus probability of B. Why? Since we subtract this term is a positive term to equate with this term, then we can write probability of A intersection B is less equal to probability this term is bigger than this. So this is an important inequality also, this. Now we come to next, and this is the Venn diagram. You already see the Venn diagram in the above. So now for any three event A union B and A, B and C, we can write probability of A union B union C, this is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. So first taking one event at a time and probability, this is a positive term, then taking two at a time, two event at a time, and the probability intersection of two probability, probability of intersection of any two events, taking two at a time and negative sign, and three at a time with positive sign. Now we extend this by for n events, this one. So for n events A1 A2 An, we write the addition theorem, probability of A1 union A2 union n, this is equal to probability of union of I equal to 1 to n ai. We can write this first single term with positive sign, so summation probability of I equal to 1 to n probability of ai, then taking two at a time, two event, so double summation 1 less equal to I less than j less equal to n probability of ai intersection aj, then plus sign, and taking three at a time, probability of ai intersection aj intersection ak, then 4 at a time with a negative sign, plus minus alternative sign, plus dot 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 plus minus 1 to the power n probability of a1 intersection a2 intersection up to an, the last term. Now let us come to another important theorem, this Bool's theorem. This is also a very important theorem for probability theory. This is also a pillar, you can say, of probability theory. So for n events a1 a2 an, we have probability of intersection of I equal to 1 to n ai, this is greater equal to summation I equal to 1 to n probability of ai minus n minus 1. So if we take two event, then if we apply Bool's theorem part 1 result, then we have probability of a intersection b for any two event, we can write greater equal to probability of a plus probability of b minus 1, this result. Since n equal to 2 here, since 2 we take two events a and b. So and the second one is probability of union of ai, this is less equal to probability of summation probability of ai, that is if we take three events, then we can write probability of a1 union a2 union a3, this is less equal to probability of a1 plus probability of A2 plus probability of A3. This. Now let us come to another important theorem. For n events A1, A2, An, we can write probability of I equal to 1 to n ai, which is greater equal to summation probability of ai minus double sum. This is double sum, or you can take any summation. 1 less equal to 1 less equal to I less than j. This is less than j less equal to n probability of ai intersection aj. So for any 3 event, if we write with 3 events, then probability of A1 union A2 union A3, which is greater equal to probability of, we can write A1 plus probability of A2 plus probability of A3 minus taking 2 at a time, probability of A1 intersection A2 plus minus probability of A1 A2 intersection A3 minus probability of A3 intersection A1. We can write this result. This is another important result. Now we come to the multiplication theorem on probability. We first starts for any two events, then we extend this. So probability of A intersection B, as we discussed about probability of B given A equal to this. So here probability of A intersection B equal to probability of A into probability of B given A, provided probability of A is greater than 0. And this is equal to, also we can write probability of B. This is another form, probability of B into probability of A given B, where provided probability of B is greater than 0. Now for A and B is to be independent, for A and B independent, we can write probability of A intersection B equal to PA into PB. And then if we put this for independent event, we also have the multiplication rule for multiplication theorem for probability for two independent event. So now if we extend this for n events, then for n events A1 A2 An, the multiplication rule is probability of A1 A2 dot probability of A1 intersection A2 intersection An up to intersection N. This is equal to probability of A1 into probability of A2 given A1, then probability of A3 given A1 intersection A2, then up to then multiply probability of An given the intersection term up to n minus 1 terms, where probability of AI given AK intersection AL intersection dot intersection AM represent the conditional probability of the event AI, given that the events AK AL dot AM have already occurred. So this is also an important theorem for probability. Now you go to the next result 10. This is an very it is also a very necessary and important result. Probability of A intersection B less equal to, we can write minimum of probability of A into probability of B, and A union B greater equal to maximum of probability of A and probability of B. These two results are also important to solve the different problems, higher math problems on statistics, like in the exams like csir net exam, IIT JAM exam, and also GATE exam. Based on this result, the questions comes in different forms. Now the next one is for any three events A, B and C, probability of A union B given C, this is equal to probability of A given C plus probability of B given C minus probability of A union B given C. Number 2 is probability of A intersection B complement given C plus probability of A union B given C. This is equal to probability of A given C. This is an result. Number 3 is if B subset of C and probability of A greater than 0, then probability of B given A less equal to probability of C given A. Number 4 is probability of A union B union C is equal to 1 minus probability of A union B union C whole complement, that is whole bar, is equal to 1 minus probability of A bar intersection B bar intersection C bar, this one. So this is known as De Morgan's law, we can say. So this is the content for the video, and these results are very important to solve the probability and statistics problems. This is the very basic theorems and result and inequalities. So if the content is helpful, then please give a like to this video, share with your friends and subscribe the channel. Thank you friends. See you again in the next video.